And so I think it's time to continue and to further remind us where it once started. And then I'm thinking about the development of the first course, the Baltic Sea Environment. So this bridge now welcomes the first keynote speaker, Professor Emeritus Lena Kautsky, Senior Advisor at the Baltic Sea Center at Stockholm University. Lena, you will give a presentation on the historical aspects of the Baltic Sea, changes in Baltic Sea ecosystems, lessons learned. Very welcome, Lena.
Thank you. I'm so happy really to have been asked to come to talk a bit about the past time, and it has really been a long time when I looked at the old film or video from the first session 30 years ago, and you realize that years has passed and you are getting a bit more gray hairs, and maybe also the Baltic Sea has gotten a bit better or worse. Take us back to the Baltic Sea. It's as we all remember, it's a young sea with low salinity and this odd mixture of marine and freshwater species. And we have, with all our output of material, nutrients, and toxic compounds, really impacted this enclosed sea for many, many years. And I looked up the old presentations that we had during the first course. I still found some copies of Life in the Baltic Sea, Eutrophication of the Sea, and Toxic Environment and Pollutants. And there were several more of these small booklets that we produced for each of the seminars and satellite presentations. So when preparing this, I thought that maybe I should give, or I will give, some very short examples from impact of nutrients. And it will be from my own perspective, because it's a short time and I had to select some special things that I thought would be interesting. I will talk a little bit about nutrient reduction in the open sea and coastal waters that we have managed to do. I will take the example of the bridge that was built 1991. We started building it and it was inaugurated between Sweden and Denmark in 2000. A bit of what we are now trying to do in restoring projects in the coastal habitats, how we have managed to reduce those hotspots that we have around the Baltic Sea, and the importance or risk of introducing new species with ballast water that comes arriving all the time. And the problem that we see with this bottle, that we really can't see what happens below the surface of the sea, which is really a tricky thing when we want to manage and get it in a better condition. So the high nutrient load of the Baltic Sea has given a large impact on the vegetation. So these red dots here, fucus has disappeared due to toxic compounds or too high loads of nutrients. Fucus vesiculosus is one of my heart species, so I need to talk about it. It has been covered by filamentous algae and drowning in this filamentous algae, and large changes have occurred along the coast. We have all these reed masses that are growing out into the sea, drifting algae and some cyanobacteria blooms. And also in some areas, we have these red algae, ceramium, that are really problematic. So the nutrient has really changed the vegetation. And we have problems with drifting algal mats that may, as shown here, cover eelgrass. Especially on the Swedish west coast, large areas have been totally disappeared during the 80s. But in the Baltic Sea, we don't see that much effects on them, but still they grow on more sandy and wave exposed bottoms. So that might be the reason. And we have many other vascular plants growing on this soft sediments. Sometimes when it's really nutrient enriched, you will see them entangled in boat propellers, and it makes it impossible to go boating or swimming in the area. The other problems that occurs now is that filamentous algae and are thrown ashore in these big areas. So this is the island Öland. Earlier we would have bladderwrack. You have seen some bladderwrack here, but there's a problem for the touristic beaches, that you have to clean them, you have to collect all this material. Otherwise, they will get into the sand and the whole beach will get really muddy and very unpleasant for touristic actions, which is really a big problem. A large change that really has occurred during these 30 years, and I think that we saw it from the satellite teaching equipment to this really nice satellite videos that we have now. Easy to work with, but we have also lots of new equipment. Satellite pictures showing the cyanobacteria bloom over the sea that makes it possible to model changes in the sea. We have lots of efficient equipment on our ships and boats going over the sea, looking at the bottoms or the water masses. We can go down with ROVs, looking at the sediment and the bottom and modeling and producing models of environmental change in this Baltic area. It's a very efficient tool, and earlier we didn't have this, now we have them, and we can get much further in our perception on what's happening in future climate change and in all other details. One of the big changes we can see from the start of the courses, we have now decreased the amounts of nitrogen, and we can also see that the input from air here is a difference, but both these trends are decreasing, which is really positive. And we have a large increase in phosphorus in the open sea also, which is a result of all the efforts that has been put into cleaning the area of the open sea. But even if we have put in so much effort in reducing the inflow of nutrients, the internal load in the deeper areas is still very large, and we still have this first picture here is the open sea, the bottom areas, very small areas with no oxygen, and it's slowly increasing from 1955 and now 2012, and the worst year was 2018 when we had the largest area with no oxygen in the sediment bottoms. So the only way to change this would be to get in oxygenized deeper freshwater, oxygen-rich water transported over the sills in the Öresund area and in the Danish Straits. But if we hadn't done anything, these models now show that the result would have been even worse. If we hadn't reduced the amount of nutrients, it would have followed this line. Now we have a little bit better nitrogen, oxygen in the sediment bottoms, in the deep areas. And if we hadn't done anything about the nutrient load of dissolved phosphate, it would have been really, really high now. But we have managed to keep it a bit less. and similar also with reduction of nitrogen. So it's clear that all these efforts that we have put into reducing the amounts of phosphorus and nitrogen entering the Baltic Sea has had a positive impact. When I looked at the old pictures from the video in 1991, I realized that there was a mention about building this bridge between Sweden and Denmark. And we had a lot of discussions about, will this really have a negative effect on the water entering the Baltic Sea? Maybe we should try to open up, make it deeper so that we could have more water coming into the Baltic Sea, rich with oxygen, so that the deeper areas could be more having larger input of oxygen. And the discussion between the scientists was very strong, and we realized that we didn't know the real effect. Would it be better or would it be worse to have this increase? So it was built so that there was no change. And still, we had another change that was not really discussed when we built the bridge between Sweden and Denmark. And that is a result that we have development of a rich benthic vegetation now in the area around. So over here, these green areas are eelgrass, large stands of eelgrass, and a really healthy benthic vegetation. And then increased centimeter depth from around 4.5 meters. Now it's almost 7.5 meters, which is really positive. And the other positive effect is that it's not possible to go trawling in this area. So the cod is really bad cod stock in Kattegat and also haddock. But in the Sound area, you have these really large, nice cod where the trawlers are not possible to go because of the boating and all other activities. So there are some of these effects that we didn't really plan for, but building a big construction like a bridge is sometimes could be positive, even if we didn't think about it. And this is also now discussed with wind power buildings, that maybe in a wind farm, we will not have the possibility to go trawling or fishing in the same way. And it could be a protected area. Now I will talk very shortly about an experiment in a small bay in Stockholm area, where they tried to reduce all the different loads into the area. So the big one is an eternal load of large amount of phosphorus from the sediments. But they also put on a fish ban. They looked at how much horses, keeping horse farms would get agriculture, small sewage treatment plants, built a wetland for pike. So before the restoration started, there was this, similar to the open Baltic Sea, it was a large area with anoxic sediment. This was treated with aluminium phosphate to bind the phosphorus. And then there was an inflow of these nutrients from the farmland. There was lots of filamentous algae and very little of other vegetation, and a lot of this fish roach. And the Säkedess was very, very narrow. And after they had done this restoration program, stopped the internal load of phosphorus by treating with aluminium, there was a rich fauna of fishes. The vegetation grew much deeper. The Säkedess was much deeper down. And there was a lot of more pike and perch in the bay. And the reduced outlet also of nutrients from the bay. So this was one of the examples now that we have done a lot of efficient work on restoring local areas, which is, of course, one of the importance that has changed from during these past 30 years. The other thing that we also have done during the last 30 years is that in 1992, we established in HELCOM a hotspot list with lots of point sources around the Baltic Sea. And the total of 162 of these hotspots where pollutants or nutrients were put out into the sea. And now in December, I looked up, we had managed to get rid of 75% of these hotspots, which is really important. There is a large reduction now of phosphate from the sewage treatment plant in St. Petersburg, which was completed in 2010. And all this effort that we have put into the areas of hotspots is cleaning up. Coastal areas, of course, will respond earlier or quicker, and the open Baltic Sea will take even longer time when there has happened so many positive things in the sea. For the toxic compounds, we have also managed to decrease several of them. So PCB and DDT has decreased, and we have now got back seals, and sea eagles are flying over the sea again. But we have some substances that still increase in amount. And as soon as we are managing to get rid of some, we get new toxic substances are added all the time. And we really don't know which effects they will have on the sea. So there is a lot of future challenges with the toxic compounds related to new toxic compounds arriving and complex mixtures. So if you just have one, we can study one substance and another substance, but if we mix them together, the risk might be that they are interacting and getting additive results that are really a problem. So we managed to get rid of and ban PCB and DDT, which have decreased, and we have this recovery of seals and white-tailed sea eagles. But now we get a large amount of new toxins that we don't really know about from the global trade. We import a lot of substances that we really have no idea of what they can do in the enclosed Baltic Sea. We have large problems now with treating drugs, pharmaceuticals that we use as medicine, and they get out into the sea in the treatment of sewage treatment plants. We are trying now to get new cleaning methods. And there is a discussion about the microplastic particles that might come into some of the small animals and get into the ecosystem. So as soon as we manage to get rid of some of the problems, we usually create some new, and then we have to work as detectives to finish it. We have also, with our ships, quite often in the ballast water, got a large number of new species entering the Baltic Sea. So we have the barnacles, which came in the 1800s. We have the zebra mussel coming here early 1910. Some big crabs from, and this curve is slowly increasing, and we get about 2 new species per year entering the Baltic Sea. And the Baltic Sea is a very species poor environment. So maybe it's possible that these are just lots of places for these new species to live and find areas to grow and establish. And many of them have really increased in number. And some of them, like this, here is a picture from one of the lagoons in the southern part of the Baltic Sea with this Chinese mitten crab, some barnacles, this is a small snail, the black round goby, and the zebra mussel. And the whole ecosystem is now composed of new introduced species, but it still functions. So the question I am thinking a bit about is what will really happen with this in the future? Is this just a problem? Is it, or could it be used in some way? And as an example, the round goby, Neogubis, it eats blue mussels and small crustaceans, and it's now a resource in a simple food web. So this is a photo of a perch who had all these fish as a stomach contents, one little stickleback and the rest was gobies. And we're also fishing them, and they are fished by quite commonly now on the Stonian coast, and you can do some very delicious dishes for us to eat. So maybe we have to also look at these new species as possible resources. And the next speaker, she will talk more about the future, but I thought that if we think about the climate change, so Fucus vesiculosus and the blue mussel, they are now occurring up here in the northern part of the Baltic Sea, around 5 per mil salinity. The prediction is that they might move all the way down here to the southern part. And then maybe zebra mussel and some freshwater species will be the ones that take over and will be creating new communities in this area. And when they have entered, we cannot really stop them. So we are discussing a lot now if we could also clean the Baltic Sea with mussel cultivations. Could we cultivate blue mussel and harvest blue mussels and then feed them to chickens, or could we use the shells to put into some feed for somebody? But last summer there was an experiment. This is the distribution of zebra mussel, which is quite common in many areas. Last summer it was a cultivation in one of the big lakes nearby Stockholm, Lake Mälaren, where they cultivated the blue mussel and used it for sewage treatment plant to clean the water from nutrients, similar to what we are doing with the blue mussel now in the Baltic Sea. So in summary, a lot has been done in coastal areas to improve the environmental conditions, and there has been a lot of work also in the innermost archipelago, for instance, in Stockholm. And the conditions were really as it were since 60s and 70s and have now been very much improved. So, and we have reduced the loads of PCB and DDT and some of the heavy metals. And we have seen all these improvements in many species and in many areas but the main message is that it really takes time to make this ecosystem to recover and populations to recover, and we really need to stop pollutants before they reach the sea, and prevent, if possible, new species. Since they have entered, they will be impossible to stop, but maybe we could also use them as resources. So we need still to learn more about how to better use and manage these natural resources produced, not misuse them, that we partly do today. And there is also a need to learn more how to restore habitats to recover up a speedy recovery process. So I gave you some links here for finding some policy briefs and other that we produce at Stockholm University Baltic Sea. And thank you for listening.
Thank you very, very much, Lena, for sharing your knowledge of the development of these 30 years. Really, really interesting to see that it has been improvements and also new challenges, of course. We have received some questions from colleagues, and I have one here from Marta Skorek. She asked, how does climate change the water exchange between the North Sea and the Baltic Sea? How does climate change the water exchange between the North Sea and the Baltic Sea?
Depending on, so far it's predicted that there are some of these big oscillations that take place, so that the water might enter the Baltic Sea if the high and low pressure puts the water over the sills into the Baltic Sea. But it is a very long time ago since there was a large entrance of new water. And I'm not quite sure that really the climate change is so much linked to getting new oxygen-rich water into the Baltic. Maybe.
Okay. We have another one here from Artur Pawlowski. He asked, if salinity of the Baltic Sea is becoming lower due to climate change, what can be done?
Nothing.
Okay.
No, if this prediction of models are true, then I can't see any way of changing a reduction. It will be lower salinity and the temperature will increase.
Okay, thanks. And then we have another one. What would you say has been the greatest research accomplishments regarding the Baltic Sea in the past 30 years?
Well, that's difficult. I think that it is that we have been able to collect so much more data and get really good models for water exchange, nutrient loads, and the work that has been done in HELCOM and the Baltic Sea Action Plan, summarizing and making possible prediction of what and how it looks like. We are getting more and more mapping possibilities and knowledge about what is really in the Baltic Sea.
Okay, colleagues, we thank you, Lena, very, very much. And we need to go to the next keynote speaker.